Hello, now we are going to discuss about sequential logic circuits. So this sequential logic circuit, if you see the difference from the combinational circuit, here we have memory element, which was not available there in the combinational circuits. So that sequential circuit, you can define the circuit in which outputs depend on the present input as well as past outputs. So where we are going to store the past output, so some storage elements are required. That's why here we have memory element in case of sequential logic circuit. The sequential logic circuit has two types. One is the synchronous logic circuits, another is the asynchronous logic circuits. So in case of synchronous, here flip-flops are used as the memory element, and when we are going to use the flip-flop, then we must have clock pulse. So in case of synchronous, we have how many clock pulse? All clock pulses, all flip-flops will be given same clock pulses. That means same clock pulse is being shared by all flip-flops. Whereas in case of asynchronous sequential circuit, here the memory element, we are going to take some delay elements that provides some delay here. And like here, if you see that we have discussion about this logic gates that is sufficient to provide here delay. So here we have latch. So in case of asynchronous sequential circuits, this memory elements we are going to use latch, and latch we know that it is the level trigger. So once it's achieved the particular level, at that level it is going to work. So this is the basic difference here. So that level trigger, that level will be given to only one latch, and remaining latch will be operated by the output of the previous latch. Due to that, we have delay here. So how much delay we are going to produce, that much here we can connect the elements, delay element 0, delay elements like this. We can have multiple delay elements here. Now we are going to talk about the latch here. So in the sequential logic circuits, these circuits are built with the help of latch and flip-flops. So latch, again, when we are going to design the flip-flops, so again we are going to use the latches only. So you can see that latches is the basic buildings for the sequential circuits. But how we are going to define the latches? So latch is the 1-bit storage, level sensitive, asynchronous device. So here whatever input we are going to give, that input will be given to the latch, but the triggering will take place with the help of level trigger, and that will be given only to the first latch. That how we are going to operate on the basis of that, it will be given to either LSB or MSB. Depends upon which type of the operation and how we are going to operate. Whereas later we see that flip-flop is also 1-bit storage, but that is the age triggers synchronous device. So now we have four different types of the latches: SR latch, D latch, JK latch, T latch. So in case of SR, this S is used for the set, R is used for the reset, and T latch, this is also called as the transparent latch, and it is very economical, which is used mostly. So later we'll see that when we'll have discussion about flip-flops, we'll see that maximum flip-flops we are going to design with the help of D flip-flops. That discussion will come. Third one is the JK latch. So this is also going to work like a set and reset. But what is the advantage? We'll see that in case of SR latch, we have forbidden condition. That forbidden condition is overcome in JK latch. And T latch is the toggle latch. So here output Q and Q bar toggle of each other's. So when T equal to 0, what will happen? When T equal to 1, how it is going to toggle each other, that we are going to discuss later. First, we'll see here more detail about the SR latch. So SR latch can be designed with the help of NAND gates or NOR gates. So first here we are seeing the design of the SR latch by using the NAND gates. So here, if you see that in case of latch, both gates, both NAND gates, that is our universal gates, are cross coupled. Cross coupled means output of one gate is connected to the input. Like here, Q is connected input to the NAND gate 2. Whereas Q dash, that is the complement, is connected to the input to the gate 1. So that's why it is called as the cross coupled connections. So now this operation of the SR latch completely depends how this NAND gates are going to behave. So for that we can recall the truth table of the NAND gates. So here we have inputs. When inputs 0 0, output is 1 0 1 1 1 0 1 1 1 0. So what you will find here similarities that when any input is 0. So if you see that here for the first three combination, when any input is 0, then output is 1. So this concept we are going to use. On the basis of that, when we have information of single input to the NAND gate, we are able to predict what will be the output of that NAND gates that we are going to see. So now for the initial condition, to understand the operation, we are taking here S as the 1 and R we are taking as the 0. And since we know that in case of NAND gates, if any input is 0, we are sure that output is 1. So here for the NAND gate 2, one input is 0. So we are sure that Q dash is going to be 1. Now Q dash is given back to the NAND gate 1. So now both inputs become 1 1. So that's why output of NAND gate 1 will be 0. So here we got Q as 0 and Q dash as the 1. So this is the first situation here. So when Q is 0, then it is called as the reset condition. And Q dash, always these two are the complements of each other. So this is the first condition. Now here we'll try to see the another condition. So here we are keeping S as the 1 itself and we are changing R to 1. Now both inputs are 1 1. So we are going to take the help of the previous outputs. So previous output here, Q is connected here. So this Q is 0 here and Q dash is connected here. That is here 1. So I'm writing same thing again. So now here both inputs are again 1 1. So output is what? 0. And here one input is 1. Another input is 0. So what will be the output? Output will be 1. So what was the earlier condition? Same output now also we are getting. So that's why even S and R is 1. If initially it was reset, it's remained the reset. Q is 0 and Q dash is 1. Similar thing, we can see the another situation. So now in this condition, now we'll take S as the 0 and we'll take R as the 1. Now for which NAND gates we can predict the output? Just think about this. You can pause yourself. So here, just recall the NAND gate truth table. If any input is 0, output should be 1. So for the NAND gate 1, now input is 0. So we can predict this output. This output is 1. Now this Q is given input to the NAND gate 2. So both inputs are here 1, 1. So output will be 0. So here Q we got 1 and Q dash we got 0. So Q is 1, so that is called as the set. So this is the condition, third condition here, combination. So this is called as set. Now it is device is already in the set, latch is already in the set state. Now we are going to change as to 1. R is 1, remain 1 only. So now again we are going to see what will be the output. So we have changed S to 1 and Q dash is 0. So here inputs are 1 and 0. So what is the output? Output will be 1. Okay. And here same 1 is given here input also to the NAND gate 2. So both inputs are 1, 1. So what will be the output? 0. So device was set. It's remained set only. Now, if you see that when both inputs are going to be 0. So when both inputs are 0, we know that if any input is 0, NAND gate output will be 1. So here Q and Q dash both is going to be 1. So here we are not able to see any difference in the output. So this combination is avoided. So that is called as here forbidden. Now we can see the SR latch with the help of NOR gate. So this is both universal gates that we are going to see now. So again, same cross-coupled connections are given here. And we are going to recall the NOR gate truth tables. So 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. So here what will have similarity that if any input is 1, then we are sure that output is 0. So this concept we are going to use here. So first condition, and here if you observe that we have changed Q dash is connected to S and Q is connected to R here. Whereas in case of NAND gate, S is connected to the Q, R is connected to Q dash. So now here we are going to take S as the 1, R as the 0. Now if any input is 1, output we are sure that it is going to be 0. So for the NOR gate 2, one input is what we have 1. So we are sure that the NOR gate 2 output is what? 0. Now this 0 is given again input to the NOR gate 1. So both inputs are 0. So output is what here? 1. So Q is 1. Q dash is 0. So now device is set to be set. Now if you try to bring this one in the initial conditions, so now S will change to 0, R will remain the 0, then we are going to see whether device will remain in the initial condition or there is any change. So S is changed to 0, R kept 0 itself. So now here we are going to take the help of the previous output. So now here already we have Q dash as the 0. So same 0 is available here. So both input of the NOR gate 1 is 0. So that's why output is also going to be 1. Now this 1 is given back here to the NOR gate 2 and one input S is 0. So 0, 1 is the input to the NOR gates. So what will be the output? The output is 0. So what we are seeing that device was set, it remained in the set condition. Similarly, we can see for the reset condition also. So in case of reset condition, we are going to take here S as the 0, R as the 1. Now, which NOR gate output we can predict? Where one input is 1. So this NOR gate 1 output we can predict that this output is what here? 0. Now this 0 is given here input to the NOR gate 2. So both inputs are 0. So what will be the output? That output will be 1. So now here we are seeing that Q is 0 and Q dash is 1. So that device is in the reset condition. So this combination we are seeing here. So now again we'll check that when we are going to make to the initial condition, what is going to change here. So here now we'll keep S as 0 itself, or we are going to make the 0. So now both inputs are here 0 to the NOR gates. So now two different NOR gates. So now we are going to take the help of the previous one. So that's why here if you see that in this case, here input is what? 1, that is the Q dash. So now NOR gate 1 input is 0, 1. So what will be the output? 0. And same 0 is given here. So now both inputs are 0. So output of NOR gate 2 is what? 1. So device was reset, it remain in the reset condition. Now here, if you'll observe that in this case of the NOR gate, if you are keeping R also 1, S also 1, then we are able to predict that output of the NOR gate 1 will be 0, output of NOR gate 2 also will be 0. So now that this condition is called as here forbidden condition. So we have observed that when we are designing SR latch with NAND gates, then S and R both should not be 0 at the same time. And in case of NOR gate, designed with NOR gate, S and R both should not be 1 at the same time. So these two are the called as the forbidden condition. So that things we have to keep in mind when we are writing the truth table. So this one here we have seen that completely we can understand the operation on the basis of how NAND and NOR gates are going to behave. And it is important here that in case of NAND gate, if any input is 0, we are sure that output is 1. Whereas in case of NOR gate, if any input is 1, we are sure that output is 0. These things we have to keep in mind. Now we have another discussion where we are going to see that SR latch with control or enable inputs, and this concept later is going to build the basics for the flip-flops. Like here we have applied the enable. So for the enable we have two different concepts is there. One we call as active low enable. So in active low enable, device will give the output, or we want that device should work when En is equal to 0. Second condition we have active high enable. So in case of active high enable, what is our desire? That device should operate when En is equal to 1. So these two concepts are here. So here maximum time we are going to see active high enables. So that concept we are going to use here. So now if you see that what was the earlier basic latch, apart from that basic latch, two more NAND gates are connected here. So for the understanding purpose, we can mark here this one 1, 2, 3, 4 to understand the operation of this SR latch when we have enable of control inputs are there. So like in case of if enable inputs are not there means this operation or phenomena of this SR latch completely depend upon what are the inputs are given to S and R. But here we can control with the help of enable inputs. So again it is the NAND gates. So we have two table of the NAND gate for our reference. So same logic is here. If any input is 0, output will be 1. So now we'll understand that this function table, which is going to help us to understand the flip-flop also. So now if you see that when initially enable is 0, then our device, this NAND gates 1 and 2 is not going to take any input. It's not going to accept any inputs from the S and R. Okay, what is the condition? When we have enable is 0. So when enable is 0, it's not going to accept any input from S and R. So there will be no change. What will be the previous state? Device will remain in the same state now also. So here in the table Qn plus 1 is used to represent the next state, and Qn we call as the present state. So now we are making this one enable. So for that we are going to take here En as the 1. So we are going to use the concept of active high enable. So now initially if you are putting S0 and also we are putting R0. So now here both inputs are available, so we can see the output. So again, this is the NAND gates, what we are marking here. So for the NAND gate 1, one input is 0, one input is 1. So what will be the output of the NAND gates? This output is what? 1. Similarly, for the another one, again, if you see that here, R is 0, R is 0, and enable is 1. So here what will be the output again? Same combination is what here? 1. So in this, if you see that when it is 0, 0 and enable is 1, there will be no change in the output. What was the previous final output? Output will remain in the same conditions. So that we have seen already earlier that in case of SR latch earlier, so what are the conditions? So now if you see here in this, if here one input is 1, here also input is 1 to the NAND gate 3 and 4. So here we are not able to predict here output also. So device will remain same as the previous condition. Now if you see that, we'll take the another combination here. So now if you'll take, suppose we'll take S as the 1 and we'll take R as the 0. And enable is already 1. So now both inputs to this NAND gate 1 is 1. So output will be what? 0. Whereas for the NAND gate 2, one input is 1, another input is 0. So what will be the output here? This output is 1. Now, if you see that for the NAND gate 3, input is 0. For NAND gate 4, input is 1. So now in this, what we are seeing here that which NAND gate output we can predict. What is the concept? If any input is 0, we can predict the output. So NAND gate 3 having one input as 0. So this output we can predict here that Q is 1. Now this Q1 is given here input to the NAND gate 4. So both inputs are 1. So what will be the output of the NAND gate 4? That is the 0. So since Q is 1, Q dash is 0. So finally it is called as the set. So this condition is set. Now if it is set, now if we going to make S as the 0 and R as the 0. So finally we have seen that here what will be the output? 1. Here also output is 1. Now both NAND gate 3 and NAND gate 4 will have input as the 1. So this whenever in both inputs, both NAND gates having input 1, then we are not able to predict the output. So that latch final output Q and Q dash will be unchanged. So that's why if device is in the set, it will remain in the set only when both input S and R is 0. That's why it's written no change. Now we can take the another condition. So of the reset. So in case of reset, if we are going to take S as the 0 and we are going to R as the 1, enable is already 1. We are going to use the active high enable. So now input is 0, 1 to the NAND gate 1. So what will be the output? Output should be here 1. And here for the NAND gate 2, both inputs are 1. So output is 0. Now if you see here in this case, NAND gate 3 having input 1, NAND gate 4 having input 0. 1 input is available here. So now which having one input at 0, for that we can predict the output. So for the NAND gate 4, we can predict the output, that output is 1 here. This 1 is given back here, input to the NAND gate 3. So both inputs are 1. So here output of the NAND gate is 0. So finally, this output is going to give us Q as the 0, Q dash as the 1. So this is the condition of the reset. So now device enter in the reset state. Now after this reset, again if you can check that if you are going to put 0 condition, means we are keeping S as the 0, R also as the 0. So now input to the NAND gate 1 is 0, 1. So what will be the output? Output will be 1 here. And for the NAND gate 2 also input is 1 and 0. So output will be 1. Now both NAND gate 1 and 2 having output as 1. So for NAND gate 3 and 4, input is available, that is the 1. 1. So finally, when both having one input as 1, 1, we are not able to predict the output here. So device output will remain unchanged. What was the earlier condition? Now we have seen that device is reset. So it will remain in the reset only. If you are going to take both as the 1, 1. So now if you see that, this is the problem with the SR latch. Both inputs at the same time should not be 1. Just like we are using the concept of active high. Enable, so enable is 1. If you keep S1, R also as the 1. So both inputs are 1 to the NAND gate. So output is 0 here. And for the NAND gate 2 also, output is 0. Now both having input, one input as 0. NAND gate 3 and NAND gate 4 both having one input as the 0 means we are able to predict the output. So this is going to be 1, this is the 1. So that should not be acceptable. So this is called as the indeterminate condition. So this should be avoided, and we'll see later that in case of JK latch, how we are able to avoid this indeterminate condition. So what are the changes will be there that we are going to notice. So here if you see that in this we have discussion about SR latch, we have designed with the help of NAND gates and NOR gate for both universal gates. So you have to remember here the basic concept, all operation based upon the NAND and NOR truth table, and we have set, reset, and some forbidden condition. In case of SR latch, when you're designing with NAND gates, then we have 0, 0 is the forbidden condition. In case of NOR gate, we have 1, 1 is the forbidden condition. Whereas when you are going to use the SR latch with control or enable inputs, here 0, 1 means S is 0, R is 1 means it is reset. S is 1, R is 0, that is the set. And when we are going to apply both input as 0, then it will no change, means what was the previous state, it will remain in the same state. And when both input S and R is going to be 1, that is the indeterminate states. So that we'll see that it is going to overcome in JK latch. And later we have discussion about the flip-flop also. Thank you. Thank you very